Hi, I'm Evan, hardware developer at Voltera. Today, we're looking at a project using RFID, a technology used the world over in asset tracking and data communication. So today we're demonstrating making an RFID tag with an innovative new nano copper ink. Specifically, we're using Copprint's LF301 ink for paper. Paper is a lot cheaper than existing substrates like PET, which current RFID tags are often printed onto. In addition to this, copper RFID tags on paper are biodegradable. Now, nano copper inks have a lot of benefits over existing technologies like etched aluminum tags or printed silver tags. The most common way of manufacturing RFID tags using etched aluminum is very environmentally wasteful and produces a lot of byproducts due to its subtractive nature. Secondly, printed silver tags are very expensive, prohibitively so, preventing mass adoption. Making an RFID tag using this nano copper ink in this project actually offers better performance. Why is that? Well, first off, if we're comparing it to aluminum tags, copper itself has a much higher conductivity. If we're comparing it to silver inks that are often used in this environment, due to the special sintering process of this ink, we actually have a higher conductivity compared to those as well. Previously, it was difficult to work with copper inks, namely because copper oxidizes. You see the Statue of Liberty? It's green. You see the top of old buildings? They're green. However, with new inks now on the market, they've solved the oxidization problem, meaning that you can now work with these inks at room temperature. So the first step of this design process is to choose the topology or type of the antenna we're designing, as well as the geometry of it. We ended up deciding with a specific topology called a dipole meander antenna, which is commonly used in RFID applications. The second step in designing our RFID tag is to simulate it. When we're performing this simulation, we're looking principally for two different things. First off, we want to make sure that the antenna is sensitive, that is to say, will have a long range. And then secondly, we're looking for an antenna that will work well in every direction, that is, an omnidirectional antenna. The third step of our design process is printing and iterating. This is where Nova comes in. Initially, calibrating Copprint's LF301 ink was kind of challenging. We started by using our standard nozzles, which are designed for silver-based inks, but this led to some poor print quality. Fortunately, after reaching out to our internal samples team, we realized that a simple change in nozzle geometry was all that was required. Once we had the ink calibrated, printing with Copprint's ink was easy. We were able to get nice, crisp, clean prints that were functionally working. Creating this copper RFID tag was incredibly simple. We didn't require any tooling, we just required the ink itself and some nozzles, as well as the machine, and then we're off to the races. We didn't require weeks between iterations, but rather we could tweak the design slightly, we could change the geometry, and then we could test it out immediately. Being able to iterate quickly with this type of project is really key because small little changes to that gap there, that width there, can lead to wildly different performance characteristics. And since RFID is very particular with having correct performance, it's critical that we be able to experiment with those. So between printing and sintering, we first had to dry the ink out as per Copprint's guidance. What this looked like is we used our in-office blast dry oven at 80 degrees Celsius for 5 minutes. Sintering is an important step in the process because when we're printing Copprint ink, what the ink looks like when it's first put down is a bunch of disconnected particles, which don't conduct electricity very well. However, after you sinter them, if you were to put it under a microscope, it would be one giant connected piece of copper, meaning it's very conductive and thus works really well for RF antennas. So once we had finished the RFID tag, we had to solder the RFID transceiver IC to the antenna we'd created. This is really easy since Copprint is copper, and solder is normally used between an IC and copper-based traces. Overall, I was quite satisfied with the tag we ended up making. It compared quite favorably to the off-the-shelf tags we bought, in fact, often having slightly better range than these tags. Not only were we able to do this all in office, but we were able to create these tags once it had been designed within an afternoon. Using copper-based RFID tags unlocks a lot of cool future possibilities. With copper RFID tags having a potential to be a lot cheaper, you can afford to put these things anywhere, not just on places where you had to justify the price, and just simplify all sorts of things out there. But on top of that, our impact on the world is going to be reduced simultaneously. Not only are our lives more convenient, but they're also better for the planet.